Nope. No. Nope. Nope. Aha, that's the one right there. Alright guys, it is time to continue on with our dozer project. This episode will be tackling the blades. The first blade we're working on is the stock blade, which we're going to add some detail to it. So let's go over that. The first thing I'm going to do, well not the first thing, but one of the things that I'm going to do is cut separation marks into the cutting edge, just to give it some more detail so it looks like plates that are on there. So I'll just be making cuts across these various points to simulate multiple plates being installed on here. On the side here, some of the details kind of goofy. What I'd like to do is take and even this edge out a little bit more. I don't like how it drops down like that. It's kind of unrealistic. I haven't seen any dozer blades that do that. The detail that they tried to add here to look like guarding plating looks like doo-doo, so I'm getting rid of all that too. So all this is going to get ground off, and then if I decide to, I'll simulate it by gluing some styrene on there. This back, all this right here is going to get sealed in with putty. I don't like that seam, it looks sloppy, so that's going to be sealed, and these are going to get sealed as well. Of course, I'll remove the paint before we do that. And the biggest and most challenging thing we're going to do on this is going to be taking all of these little interproximal areas here and drilling all of them out. I'm just using the razor saw here and cutting in the little marks to isolate the cutting edges on the blade. Alright, so got all those cuts in there. Now we're just trying to clean or cut in a little bit of a score along the back of here just to create a little bit of an illusion, make it look like these were laid on there instead of just being all part of the same model. A little bit of an undercut there. It's going to be difficult to make it look truly like these were laid on after it gets painted, because the paint's going to want to fill that in, but I'm hoping that this undercut that I'm scoring into here will create kind of like a little bit of a valley for the paint to kind of drop down into. It's hard to explain. So like when I have models that have like undercuts like this, sometimes the paint doesn't want to drop in there and fill it all the way. It kind of goes to the edges of it, and it kind of helps to create this illusion that the two parts are different. So that's what I'm trying to accomplish here. Let's just give it a little bit of a valley, so that later we'll get some separation. Going in one direction, then I'm going to flip it around and then go in the other direction. It's hard to see on camera, but it is drawing out like a little bit of material there. Alright, so the last little bit of detail I did was I took the saw blade and I cut under here because this all was kind of connected. So I made a little bit of an undercut in there just to create a little bit of visual separation. And then I've finished creating this little undercut there. So hopefully when it's time for paint, that'll create a little bit of a visual separation. And then I grooved in these little spots right here. I may go back and make these just a little bit deeper. But yeah. That part's done, so next part I'm going to do after I just touch these up is grinding off the bottoms. Alright, as you guys can see, I'm using a little bit of a different setup here. This is pretty much a full-size 4-inch drill press vise that I've attached to the top of my little compound table on my micro drill press. So it's a 10-gallon hat on a 5-gallon head, so to speak, but it's all I've got to work with for right now. And I needed something that was going to get a solid grip on this and hopefully hold it in place. To make sure that this is all lined up, I used my little machining square, and then I also used this little tiny level to make sure that this leading edge right here is level, so I get some good straight-ish cuts. The reason I say straight-ish is because, like a lot of casted things, nothing is perfectly straight. This blade is not perfect. There's no lines on this are actually flat. It's all a little bit wonky. Alright, one hole down, a whole lot more to go. Alright, so I got the first one done. That wasn't bad. I was able to run a bunch of holes through it. I think I did about 3 holes, and then I was able to run this through the channel without it fighting back at all, because there wasn't a whole lot of resistance, and cleared it out pretty well. So I just have to redo this, what, 20 more times? Let's count it out. 1, 2, 3, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Alright, so this whole process turned out better than I expected. It definitely exceeded what I thought would happen. It's pretty cool. Still need to go back through with some files and little sanding sticks and clean up the interproximals, because you can see like the little ridges. But for the most part, it turned out great. Just took my time. Made sure I used a lot of WD-40 to keep the bit lubricated. Made shallow passes when I did the little milling work, but it came out good. Used the same drill bit for the whole thing. I was able to, I just sharpened the tip on it once on my belt sander, and it was good to go. Kind of goofed up. I glued these little guys on the corner before stripping the paint, so I have to pop those back off. strips of paint, and this thing's ready to go. I said earlier that I was going to fill these with putty. Well, there's a little bit of mobility in the back here. If I fill these with putty, I'm afraid that I would probably crack it out. So what I'm going to do is just take a little piece of styrene and just cut out a piece to cover these rivets in the back. Make it look a little cleaner. But other than that, it's pretty much done. I like the way it looks. A lot more detailed. It's amazing what happens when you just do something like drill out spaces in a blade and add a little bit of detail in here. So now that I've finished the blade, it's time to work my way back towards the machine again and start to modify other parts that I think need a little bit of modification. Next we're going to work on the arm that holds the blade. There are quite a few details about this that are specific to the R model that I'm going to try to change over into the N model. Let's start at the back here. You can see this is the coupling. On the R model, it is a little bit more flared out on the back. In this die cast in particular, it's really wonky looking. It's like this big old ugly cube. It's not supposed to stick out that far on the N model, so I'm going to modify that. And I'm also going to modify this point. It sits up a little too high. For the R models, it actually has two attachment points, a higher one for the carry dozer and then a lower one for the basic dozer. So the modifications we're going to make are as follows. So here's one that I've already mocked up a little bit. You can see I plan on cutting that down, and re-drilling a hole. And then in the back here, I've already gone ahead and ground off the top of it and got it close to where I want as far as thickness. Another feature that this has that I think is really ugly is it's got this opening in the back. So if you look at it, they over-engineered it to make it probably a little bit more toy-like. So we're going to simplify it a bit. Grinding that down, which leaves us with a little bit of a problem. It doesn't want to retain as well, and it's got this little lower point inside there where the pin rests. Now once I've ground the top off, obviously we lose that retention. It will come right off. So I've figured out a solution for that. This is some 6mm tubing. It fits inside there nicely. Better light here. And then I have 5mm tubing, which will slide into that to act as a shim, which will allow it to fit over 4mm tubing. Now, why 4mm tubing? Why not just leave it like that? Because what I'm going to do on the chassis here, I'm going to actually cut that off and then drill in and replace this with the 4mm tubing so that it will act as a new post for this so that it can rotate. The reason I like the 4mm tubing is because the stock pin that comes with will fit inside it. I may need to cut off the this rough retention area and slide it in and just glue it in. That's how that'll work. And then to finish it up, I'll probably create like just a little top piece that I can glue down over this. These little ends are going to get ground down to look a little bit more appropriate. And then on the back here, I will cover it with a piece of material and we'll clean it up. Alright, so we're beginning on the base frame for the push blade, and I have got the very beginning of it started. We have some, I think this is 6mm square tubing, and then 5mm, actually I think it's 4mm square tubing in the bottom, and then a guard plate on the base. And this is the part that will be mounted under here. This is far from complete, obviously, but I'm going to create some mounting points underneath the chassis, and this will be attached down there. Alright, so it's time to create that vertical part. I've done all the measurements for it. Got that going on here. So it's not on the camera. 19, then 9 inches, or 9mm on the top, 19.5 on the back, and then 15 on the bottom. Alright, so let's measure out. Cool little trick for the miter boxes. A lot of them have this little ledge on there. It's meant for putting it against a desk, which is stable-ish. But I find that it works great to put them in a vise. Lock it down. Gets a pretty good hold on it. 90-degree bend. Nuh-uh, it's not a 90-degree bend. You fibber. Was 90. Looked like a 90. Apparently it's not 90. Getting there. From the bar. 90-degree bend. Here it goes. Just using this to hold it so I can fix this 90. What happened is when I was bending it, the 90 got pushed up against the back of the block. Right to my line. Looking good, Charlie Brown. Ooh, excite. I'm going to have to trim a little bit off the end there, but that needs to get shortened. It lines up. Because of how thin this material is, you don't want to cut it this way. You'll end up taking teeth off your blade. So I have to do it this way. You can throw a little bit of an angle on it if you want. It'll get you a little bit better bite. And you don't want to press down too hard on the vise because you'll end up warping the blade, which will not enable a straight cut and it will screw your teeth out. So just things to bear in mind if you decide to use this tactic for cutting through material in a vise that's flat. Flat material, not a flat vise. Or is it a flat vise? I like to do basically a modified score and snap and clean the edge up with a saw or a file. Hit it at a bit of an angle, take the rough side off. Don't do it too much or you'll create a knife blade out of it, but just get that flash off there. Sometimes you'll see me go like this. That's usually after I've confirmed that I've gotten all the shavings and stuff off there. You don't want to do this if there's a risk of little shavings being on there because you'll get yourself a nice brass splinter. Alright. Starting to come along. Alright, slight redesign has to happen. This piece I'm going to have to make where's the camera? This piece I'm going to have to make wider. But this isn't going to completely go to waste. What I'm going to do is this plate right there is going to be cut off and used to seal this closed, and then I'm going to remake this piece wider so that it comes out about half the width of that, and then the attachment points that these guys are going to attach to are just going to have to be farther out. I totally forgot. I could have just taken this and looked to see how wide this was going to have to be, but I got so caught up into building and designing this, I had totally forgot that I need to measure the width for these. Now another option would have been to take this part and rotate it over, and then I could have had this sit in sideways and like pinched these inwards, but I think that looks really bad. I didn't like how that looked, so I'm going to leave it the same width, but it's just going to have to take a little bit of creativity to make that look different. Alright, so I took a little creative freedom here. So originally we had the center support was going to sit in the middle there. Now I've taken and made it wider. It was originally 21 millimeters wide. It is now 26 millimeters wide. And then the top profile was originally 9 millimeters long, but I've changed it so, slipping around that way. Change it so that it's 11 mil on the top, just to kind of make it look a little bit more size appropriate. The next thing to do will now be to redo how these go on here, those side covers, and don't believe I'm going to leave the ear on the top of it because it's still much narrower than the hydraulics, so I think I'm just going to I'm going to cap those with this, create that little outer support, and then off the top of here is going to be one solid piece, that is going to have the attachment points on it. Those little cuts we made there on the side are intended for these pieces that I have here in the vise. So the reason they're in the vise is because, again, we have multiple seams for soldering. There's a seam there, and there's two seams on the outside that are holding all this together. So by putting it in the vise like this, I'm able to soak up heat away from these seams and also keep everything pressed together so nothing comes undone. And basically what I did was create little horseshoes out of solder, looped them over this, and then heated these, and then heated the main piece, and it fused everything together. So, and now these are going to be cut at an angle or ground off at an angle, and then the little boxes, which I have glued together right now, that are going to hold the spring, pretend that one's not there, will sit in place, and then I will drop a little loop in this way, trying to finagle all this together here. Ugh. So this piece will be there, and there will be a little piece right there, and this is what's going to be the outside of what holds the hydraulic. Obviously it's going to get ground into shape, and it will be a little bit wider than that, and then I will drop another piece in there to grab the other side, and that will be the next stage that I solder together. So this is what we've got so far. It's starting to get kind of heavy, which is good. Alright, so let me show you where we are at now. So here's those top pieces that I soldered in earlier. Got them ground into shape. They're still a little too long, but I'll bring them back in once I'm done. The parts where the hydraulic is going to hold on to, where this thing is going to come down in and secure, this is it. I'm not finished. Still got to shape it out, but as far as being soldered, it is done, and that will get soldered onto here. And then this profile right here is going to get shaped out. It's actually better if I do it this way. So that's going to get like almost a triangular shape to it. And the way I did these is just two little L shapes soldered together. Ah, the slow zoom. Oh, that's actually probably cool enough to take out. So just held it together with an alligator clip, put flux in all the areas where I wanted the solder to get to, and just hit it with the torch on the bottom. Then the solder and the flux became one, and I got some pretty good results. The measuring skills aren't too bad either. So these will just get ground out. And then the final stage of this thing is going to be soldering all of this together. These are the boxes that are going to hold the springs to close the back and to give it a little elevation. I'm just putting it in an L, and then that will get soldered together and ground out. And all this happy jazz will get installed on top of here. Like such. Obviously it'll be shaped out and splendid looking, but just kind of a rough mock-up what we got going on. Sometimes you gotta go to extreme lengths to keep things from coming apart from heat soak. So you can see I've got various vices and such holding all this together just to solder these pieces onto here. So what I'm going to end up doing is flipping this upside down, and then the solder will go in that little spot right there, around this, and then I'll torch it, flip it back over, take these off, and then install the top parts. Probably difficult to see what I'm talking about there, but that's the joy of torch soldering, but it's the cheapest, most effective way that I've found to solder right now. One of these days I'll get a resistance soldering unit, but still that doesn't answer all of your needs. I'll still be doing torch for some stuff. Alright, please excuse the mess on my desk, but the top portion of this piece that goes on top of here is pretty much done. At least all my soldering is done. It's pretty cool. Kind of looks like a robot crab or a crab sculpture. But there's just two boxes where the springs will go. I'm actually going to use the smaller springs. I'm pretty sure I mentioned that earlier. I'm going to cut them in half. I'm going to try to use some heat shrink tubing on the outside to make it look more like a shock absorber than a straight up spring, but the part's good to go. It's all soldered together. It was relatively complicated to figure out how to do all the soldering on this without goofing it up, but I think it came out good. A little bit of acid I still got to get out of there, but I'm pleased with it. It was a lot of work. Still got to grind these ends down and make them match up with that. And then I got to drill the holes in here and put together the spring system, and then drill the holes in here where the hydraulics will drop down into. But came out good. I'm happy with it. I thought it was going to be easier than it was, but it wasn't. I think that's the case with everything, right? Yeah. Last thing to do will be to solder these two pieces together, but we'll cross that bridge when we get there. Next thing I need to do also for the bottom is I gotta cut out the insides of this, because it's going to be where it connects to the blade. We'll cover that later as well, but it's starting to look like the bottom of a push blade system. Alright, so now that we got most of this done, we need to find a way to attach it to the bottom of this. So humming and hawing over a couple of ideas, but the one that I have settled on is going to be pretty simple. So we got our metal that we're going to use to attach it to the bottom. So let's start getting it knocked out. It's going to be just a basic strip with two loops that hold it in place. So I'm going to make the first anchor points here out of brass. I like to use wood. Get my initial bend started. My initial bent start. Now that I've kind of established that line, I'm going to flip it around, lock this line against that far piece. Get my little brace hammer there, because I find it to be a little easier to hammer this in this direction. And I'm hammering and striking right where I want it to bend. I'm not heating it. I'm just doing a cold bend. It's pretty thin metal, and when you heat brass, it actually weakens it. Actually, it weakens it if you cool it in water, so I've been told. But I find that if you heat brass, it still weakens it. Alright, so we've got our first L bend in there. I need it to be as wide as this, because this is the part that's going to fit into this channel. So I'm going to take and mark that. Alright, I realize that it's not going to be possible to get two 90-degree bends that close together. Such a long piece of material. So the first one is going to have to be down on the vise, and then the second one on here. And again, I like using the vise because I could get a straighter line. I'm going to do this just a little bit outside of my previous, or where I marked it, because the parts are going to get painted, which is going to add size or thickness, and then I'm going to put probably a couple washers in there to ease the motion. So I want just a little bit more room so I don't get a tight fit where I have to compromise the paint. Again, I'm always going to be flipping my models over and looking at the bottoms, but I like to get as good of a finished result as I can. Something I don't like about these is it does create like a little crease in there. So we're going to try to flatten that out. See these little pliers. So lesson learned from that. On the next one, I'm not going to try to get that close to a 90-degree bend with this in this material. I will do it partially and then the rest of the way with this. And also I had to resharpen the edge of this because I tried to bend some material that was too thick and I left like a little notch in the blade. So there is a possibility that I may have sharpened it too much to where it's trying to cut the metal instead of just bend it. Let's see how this fits in there. Good, we got a little bit of a gap. Hopefully it's not too much of a gap, I don't think so. Looks good. That'll allow for paint and then a couple of washers. So there's finally a company that has released 62-inch bandsaw blades in the 32 TPI measurement, and they offer them in both 1/4 inch and 3/8 inch blades. This is a 3/8 inch. I'm extremely happy about that because I've been using the 24, which is cool, but for cutting thinner metals, I feel that it is a little too quick. So this is actually going to be the maiden cut for this blade. So let's see how it goes. Oh, like butter. Nothing like a brand new blade and nice loud bearings. I lubed up the bearings, they're all loud now. Probably should have used grease. Alright, so we got our nice little unfocused channel. You guys get the idea. as all the stacking and grinding is done. The reason I stacked those multiple sections of box in there was just to give me a much firmer thing to build on, so when I pin it together I don't have to worry about crushing any of the brass. These little guys slide in like that. And then this part is going to be mounted to the bottom of the dozer. And I will drill pinholes. Voila. I'll have a mounted dozer blade. The holes are drilled, however there is a little bit of room in there, which I anticipated. I'm going to make some plastic washers to go in there. I'm actually going to pin this together before I paint it. It's going to be on the bottom of the dozer, and I don't feel like trying to pin it together later, so this portion of it's going to get pinned before paint. So, to make a custom washer, take a nice thin piece of poly, my handy dandy punch here, line the hole up in the middle. So I'm looking down through the hole in the top of the punch and then lining up the hole that I just made in the poly. Drop the pin in. Press it down. Voila. Not perfect, but it'll do. Now the fun part of trying to get it in there. These are just a pair of these. I took and I bent them in specifically for the task of doing this. It flares the ends out. And that was 2mm tubing that I put in there. So now I got a nice, no jiggle, nice solid fix. And then this will get put together like this. You got a nice little joint there. It's a nice joint, man. Here I got the base of this all squared away. Both these are pinned on, and then I took this and super glued it down, drilled 2 holes in it, and I attached these 2mm bolts. See where they come off in the back. They're actually a lot longer. I just cut the excess off. And then I used super glue like a thread locker, held that in place so that everything fits under the hood nice and secure. Then this will get attached later once I paint the model. It's a little fidgety to get on. So we got a nice blade system. The next thing I need to do obviously is to drill the holes in for that and then drill the holes down in there, but it's starting to look push caddy. I'm pretty happy with how this is turning out. It's been a lot of work, but it's definitely worth it. It's coming out cool. And the super glue might have held this entirely, but I threw those bolts in there just to kind of give me a little bit of a safety net. And then once it gets painted, this gets glued onto those slides. It looks pretty legit. I like it. Alright, we got to finish up some little odds and ends here. You can see we have this little hole right there. That was for the cross stabilizer bar that used to go in to stabilize the blade when you're tilting. We don't need that anymore. But on the life-size machine, it's not actually a hole. It's a little knob that sticks out that you would attach the bar to, and oddly enough, it looks a lot like the head of a finish nail. First, I gotta make the nail a little bit shorter. What I am gonna do is put a piece of wood right here because I don't want to mar up the head, because I actually want it to stay looking nice. It's kind of hard to see because these are all the same color, but looks like it lined up pretty well. See that red line right there? This is where we're going to bend it that way. The wood is proving to be a little soft, which is what I was worried about when bending this little of a mount. Nails always bend when you don't want them to bend, and then when you want them to bend, they don't. I ended up just hitting it with the hammer without the wood block because the wood block wasn't applying enough pressure, but I was able to get the result that I wanted. The JB Weld Quick is nice. It's a bit of a misnomer. It sets up very quickly. It still takes about 4 hours to cure, I believe. But you have about 4 minutes of working time with it. I think I went past it a little bit longer. If you take and start manipulating it after that 4 minutes, you'll notice it gets it doesn't really stretch anymore, and the surface of it gets a little bit matte in its finish. So it gives you a good minute warning that it's time to wrap it up and finish whatever you're working on. But it's cool because in that last little bit you can start laying it on where you want it to build more. Like this last little bit right there, I built it up a bit, and then later once it's in its first bit of curing before it's fully cured, but where it's no longer really malleable, I'll come back with a blade and clean this up before it hardens too much, and we'll just let that set up and do its thing. Come back later and clean it up. Alright, a little more satisfied with that. I just did one bend. That will be the part that I glue, and then there's this little instep right there. This drops down into it. I'm going to grind this back a little bit more to even it up, but I feel much better about that than just leaving it bare like that. It's a little more complete. So earlier I mentioned cleaning this stuff up while it's still a little bit soft. It's been about 2 hours. And it's kind of in this rubbery state now, so I'm just going to come through and gently start cleaning some of it up. That's the blade here. Okay, so that concludes this portion of the episode, making the base frame for the pushcat assembly. As you can see, there are still more things to do on this, but I'm not going to do those parts until I make the blade, because I need to have it in place to figure out how long I need to make the springs, where to put the stop blocks, and all the other details that go into that part of the build. So in the next episode, the entire episode will be making the pushcat blade, and then we move on to rippers and the other stuff. Only a couple episodes left until this monster-sized project is finished. As always, appreciate you guys watching. Like the comments, subscribe, thumbs up, whatever you got, I'll take it. See you guys next time. Adios.